Hey guys, so today we're going to be building off what we talked about last lesson with different types of compounds and actually really digging into how different ionic compounds form as well as how different molecular compounds form. We'll also be going over kind of how to identify the different charges of ions using the periodic table, which is really important. Okay, so this lesson is all about ionic and covalent bonds. Ionic bonds being the bonds in ionic compounds, and covalent bonds being the bonds in molecular compounds. So we're going to talk about, again, how these different bonds form. You also have to be able to draw diagrams of these molecules and their bonds, and then be able to differentiate between ionic and covalent compounds. So first of all, ions form in order to try and become more stable. So remember, according to the octet rule, atoms are most stable when they have full orbitals. So in order to try and get full orbitals, some elements, metals, will lose electrons, and other elements, usually our non-metals, will gain electrons. So for example, all elements in group 1 have one electron in their outermost orbit. And so they just want to lose that electron in order to become stable. And I'll kind of go over what this will look like for all the different kind of columns on the periodic table. If we look at our non-metals, like in group 16 and 17, those ones already have close to a full outermost orbit, so they just want to gain electrons to try and become fully stable. Ionic bonds always form between metals and non-metals. The metals always lose electrons to become cations, so positive. And then the non-metals can gain electrons to become anions, so they will become negative. Remember, electrons are negatively charged, so when you gain an electron, you gain that negative charge. And then the positive and negative anion and cation will attract one another just because they're oppositely charged, so just like opposite ends of a magnet. And that's what that bond is. An ionic bond is just attraction between oppositely charged ions. And we draw Bohr-Rutherford diagrams for this, and I'll walk you through how to do that. We are going to be using Lewis dot diagrams to do this instead of full Bohr-Rutherford diagrams. Lewis diagrams just have the element symbol in the middle and then the valence electrons drawn around the outside. So let's pause for a minute and go over that. Okay, so what I have here is elements kind of going across the periodic table from left to right, representing essentially group 1, 2, 13, 14, 15, 16, 17, 18. So if we look on our periodic table, I've just gone across this row right here: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, skipping this little dropped down section here. And so essentially what we have, the first thing I want to look at is the number of valence electrons. Which we talked about when we learned how to draw Bohr-Rutherford diagrams in the last lesson. So valence electrons are just the electrons in the outermost orbit. So anything in group 1 has 1 valence electron, group 2 has 2 valence electrons, group 13 has 3, 4 in 14, 5 in group 15, 6 in group 16, 7 in group 17, and 8 in group 18. And so when we're drawing Lewis dot diagrams of this, essentially all we're going to do is draw just the symbol and then the valence electrons. So just the electrons in the outermost ring. And so what that means is that every single element in a vertical column of the periodic table will look the same except for the symbol in the middle. So for example, if we look at this column right here, fluorine has 7 dots around it because it's in the 17th column, so it has 7 valence electrons. Chlorine would also have 7 dots around it, so would bromine, so would iodine. The only thing that would change is the letter or letters in the middle. And then neon would have 8. And so when we're trying to figure out what the charge of these different ions would be, oopsies, why can I not write today? Ion charge. Anything that is in this first column, in order to become most stable, it needs a full orbital. Now, it could try and get 7 more electrons in the outermost orbital, but it's easier to just try and lose that outermost electron. And then its next orbital is full. And so the easiest thing for lithium or anything in that first column to do is lose an electron, which would give it a charge of +1. Beryllium, easiest thing for it to do, or anything else in the second column, is lose 2 electrons, so it would have a charge of +2. Any ion from the second column, so beryllium, magnesium, calcium, would all have a charge of +2. Boron, easiest thing to do is lose 3 electrons. So anything in that column will have a charge of +3. So that would be like both boron and aluminum. Now, carbon is interesting because it could lose 4 electrons or it could gain 4 electrons. And that is what usually happens. So its most common charge is -4. Nitrogen, it is easier to gain 3 electrons than lose 5. And if it can gain 3 electrons, it will have a full second orbital. So it usually has a charge of -3 from gaining 3 negative electrons. Oxygen or anything else in oxygen's column would have a charge of -2. Fluorine, -1. And anything in the column where neon is already stable, so it doesn't form ions. So we'll just say it has a charge of 0. Okay, so both valence electron and ion charge is something that you have to have memorized for columns 1, 2, and then 13 through 18. Okay, so this is important to memorize based on the periodic table. So again, if we're looking at the periodic table, anything in this column will have a charge of +1, +2, +3, +4, sorry, no, I'm lying. +1, +2, +3, -4, -3, -2, -1, and 0. So now let's talk about how to use these different Lewis dot diagrams that I've drawn here to actually show how these ions will bond to one another. So we'll go over, let's say, MgCl2, which is called magnesium chloride, and we'll get into how to name things at some other point. So MgCl2, what this means is that we have 1 magnesium and 2 chlorines. So I'm going to draw my magnesium, And because magnesium is in the second column, it is going to have 2 valence electrons. This is why you have to have your valence electrons memorized so you know how to draw your Lewis dot diagram. And then chlorine, being in the 17th column, is going to have 7 valence electrons. And this little 2 here tells us there's going to be 2 of them. So I'm going to draw 1 on either side of the chlorine. Then I'm going to show how the ions are formed. And with ionic compounds, ions are formed through the gaining and losing of electrons. In this case, magnesium wants to lose both of its electrons. Each of my chlorines need an electron. And so what's going to happen is the electrons will leave the magnesium and go to the chlorine, like so. Once that happens, our chlorine ends up with a charge of -1 or 1 negative. The magnesium is going to have a charge of +2 or 2 plus because it's lost 2 electrons. And then the other chlorine will also have a negative charge. The last thing we're going to do is we are going to draw our valence electrons as they now are. So my chlorines each now have 8 valence electrons. And because my magnesium has lost its valence electrons, we're just not going to write anything around it. And we finish it off with some square brackets around each ion. So now we have a chlorine ion, a magnesium ion, and another chlorine ion. The brackets where they kind of touch each other or where they're beside each other is where the ionic bond is. So here and here, we have the ionic bonds that are really just a really strong attraction between a positive and a negative ion. It is important to note that when you're doing this, you can't have 2 negatives or 2 positives touching each other because that's not how attraction works. So the magnesium and chlorine have to be beside each other. If you had drawn it like a magnesium and then the chlorine and then the other chlorine, okay, that is incorrect because you cannot have 2 negative charges with an ionic bond or a site of attraction between them. You can only have oppositely charged things touching each other. Okay? Okay, so that is how we would represent ionic compounds with Lewis diagrams. Then we get into our molecular compounds, which are held together with covalent bonds. A covalent bond always occurs between a non-metal and another non-metal. There is no loss or gain of electrons, so you have no ions forming, nothing that's positive or negative. Instead, the elements share electrons with each other. And essentially what happens is the nucleus of one atom becomes attracted to the electron of a different atom, and then they share that electron. It is important to note that only unpaired electrons can be shared. So if we were to look at our Lewis dot diagrams, any electrons that are side by side cannot form a bond. Only lone electrons can form a bond. And so we'll go over how to draw the Lewis dot diagrams for molecular compounds as well. Okay, so the first example we'll do of this is nitrogen phosphide. So I'm going to draw my nitrogen. It's in the 15th column, so it's going to have 5 valence electrons. My phosphorus is also going to have 5 valence electrons in the same column as nitrogen. And then any electron that is by itself must end up in a bond. Electrons that are in pairs cannot be bonded. At least that's the rule for this year. You also cannot bond two electrons that are around the same letter. So I can't bond like these two together. So what I'll do is I'll start by saying, okay, those two electrons can bond to each other. These two electrons can bond to each other. I can't stop there. I still have electrons that are by themselves. So those two electrons will bond together. When you're done, every single lone electron should be inside one of these little sausage things. Your paired electrons should still be in the pair, not in a bond. And then all I do to kind of finish this off is I just count the number of sausages between my letters, and that's the number of bonds we have. So because there's 3 sausages, I have a triple bond going to my phosphorus, and then we do still draw the paired electrons, the ones that aren't inside the bond. Okay, let's try another one. I am going to bond, let's say, oxygen with chlorine. So I'm going to start with my oxygen, which has 6 valence electrons. Then my chlorine has 7. And I'll form a bond between them, create my little sausage. Then you'll see this oxygen has a lone electron left over, the chlorine doesn't. And that's not allowed. I cannot have any lone electrons not inside a bond. So what that tells me is that I'm actually going to need another chlorine in order for all of the lone electrons to end up in a bond. So the way I would end up drawing this is my oxygen with its paired electrons, and then a single bond to each of the 2 chlorines. Like so. It is important to note that when you're drawing these paired electrons around your chlorine or your oxygen, they cannot be on the same side that has the bond. So I couldn't draw these 2 dots on this side. Okay? The bond has to be going to an empty side of the chlorine molecule. Now, when you're doing these, the first step that I've shown here is what I call a sausaging method. It is a good idea to always start by doing the sausaging method in order to get to this final step here. But the correct answer is just this final step. So as you kind of get more used to this, many of you, especially by the time you get to Chem 20, might be able to go just directly to this last step here. But I would recommend, for now, starting with this sausaging step, as opposed to when we're doing our ionic compounds, where you do actually need to show me both steps. Okay? Okay, the last thing I wanted to talk about is just alloys. So ionic compounds are a metal with a nonmetal. Covalent is nonmetal with nonmetal. So people often wonder, what about the metals with other metals? And the answer is metals don't bond to other metals. They will not chemically combine. However, you can mix metals with other metals to form solutions. So that's a physical reaction instead of a chemical reaction. They don't form compounds, they form solutions. Those solutions are called alloys. So what I would like you guys to work on now is to just go through the list of these different compounds on these 2 pages and draw the Lewis dot diagrams for how these ionic compounds would form and how these molecular compounds would form.